Hey, what's up guys? This video is for section 02, which are real numbers, and this is part 2, second video for the section. If you guys haven't seen the first one, go ahead and go back, watch the first one, and understand what are real numbers. And now we are going to look at those real numbers on a number line and have to compare the numbers from each other. One is bigger or one is smaller. So first, let's go ahead and remind ourselves where can you guys place a number on a number line, because you guys can use it, a number line, to compare one number from another one. So here you guys see a number line, and just a quick review for you guys. On a number line, we have the integers, which are negatives and positives. Usually in the middle of the number line, there's the zero value. Doesn't have to be in the zero, in the middle, that's what I meant. In the middle of the line, you guys can have the zero way on the right side of the line or the zero way on the left side of the line. It just depends how you guys want to set up the line and how many units you want to use. But usually, we do have it in the middle. On the right side of the zero, we have the natural numbers, which are the positive integers or the positive numbers, and we usually go by whole numbers, 1, 2, 3, 4, 5. You guys can start using rational numbers, which are fractions, but for the most part we use whole numbers or natural numbers, okay? Or you guys can say integers. On the left side of the zero, you guys have the -1, -2, which are the negative numbers, and it goes, when you guys look at the line, this here, it has an arrowhead, so that means that it goes to negative infinity. It just keeps going to -6, -7, -10, -100, -1000, all the way to negative infinity on the left side. On the right side, same thing. You guys have the arrowhead, and it goes to positive infinity over here. Now, the actual signs that we use for infinity, you guys have seen it before. It kind of looks like an 8, but it's laying down. So this right here means positive infinity. And over here, we have the negative infinity. So the numbers go to infinity, to the positive side and the negative side. Now, how do you know to compare the numbers? Well, first of all, let's go ahead and understand the left side of the zero and the right side of the zero, okay? So when you guys have numbers, anything further left on the number line is less than the other number. So this is what I mean, guys. If you guys look at the 1 and the 2, well, 1 is on the left side of the 2. So that means that 1 is less than 2. And that, you guys already know that. But when you look at the negative numbers, well, this is where it gets a little bit tricky, because you do have negative numbers, and there's the negative sign on the left side of the number. You guys have a -3. Let's look at this number here, and the -2. Well, -3 is on the left side of -2. So that means that this number here is less than -2. And I know, guys, that some of you guys probably learn that the further away from 0 on the left side, the number is smaller. And on the right side of the 0, the further away from 0, the number is greater. You guys probably heard that before, but this is just another way so you guys can understand. And notice what I did here. Left starts with an L. Less starts with an L. Left, less. Now, anything further right on the number line is greater. I know that's not how you spell right. It has a G at the beginning, but notice it has the little red wiggly line on the bottom. It is spelled wrong, but what I'm trying to tell you guys to help you remember is if you guys put a G in front of the right, you say great, and greater starts with a G. So anything to the right will be greater. And notice that you guys have a G and an R at the beginning of the word, G and an R. So great means greater. So what does it mean, guys? If you look at a number, let's say the -1 here, and let's pick another number, 3 over here. Well, 3 is on the right side of -1. So that means this one is greater, because this is on the right on the number line. If you guys pick another 2 numbers, let's pick some negative numbers. Let's say the -5 here and the -4 over here. Well, which one is greater? If you look at the -4, it's on the right of the negative 5, great. So that's the greatest number. It is greater, negative 4 is greater than negative 5. The number line, it helps us give a visual to see where the numbers lie between numbers, okay? Or you guys can compare different numbers. Or you guys can look at the distance. How far away is one number from a second number? That's why we use number lines in mathematics. We also use number lines to graph, to actually, you can say, plot different points. And we're going to use those points later on in this class. But right now, you just need to know how the number line works and how to compare the numbers. Now, let's talk about those great and less numbers. So over here, you guys can see that I do have two pictures. It looks like Pac-Man. But inequalities is something that we use to compare both different numbers. So the greater, less than, greater than or equal to, less than or equal to, those are called inequalities. And if you guys don't remember the symbols, here's the less than, and here's the greater than. So this symbol means greater than. Remember that the inequality is hungry and wants to eat the bigger value. So what I'm trying to say is, like Pac-Man is always trying to eat those dots in the game or to give you guys points. So same thing here. The Pac-Man wants to eat the biggest number so you guys can get as many points as you can. So when you guys compare two numbers, negative 10 for example, and negative 9 over here, well, Pac-Man is eating the biggest number right here. Negative 9 is greater than negative 10. Now, it is a little bit confusing because, yes, this number is greater than. But when you guys read the statement, you guys are going to start reading mathematics. This right here, we say negative 10 is less than. Notice how the inequality is pointing. Oh, it's eating the number on the right side. So this one, negative 10 is less than negative 9. That's how we read the statement. But even though we say less than, we understand that this number is smaller than this number, and Pac-Man is trying to eat the biggest number. Now this one over here, 5 is greater, so that's the symbol right here, greater than negative 2. So Pac-Man is eating the number 5, it's greater. Now how do you know which number is greater than? How do you know which one number is less than? Well, that's where the number comes in. I'm going to show you guys the negative 10 and the negative 9. So on the number line, notice I'm putting my arrowheads on the sides. That's the number line. I'm not going to put the 0 in the middle because I do need to go to the negative 10 on the negative side. So there's the 0 over here. I'm just going to put a positive 1 here just to give you guys a point of reference. But there's a positive 1. Here's the negative 1, the negative 2, the negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 9 is right here. So notice I'm not going to put all the numbers on the number line, but we do see that we have the negative 10 right here and the negative 9 over here. So negative 9 is bigger, greater than negative 10 because it's on the right. So that's why Pac-Man is eating negative 9. But again, don't get confused. The way we read the statement is negative 10 is less than negative 9. Now you guys can look at it the other way. Negative 10 is on the left, so it's less. Negative 10 is on the left side of negative 9. It's on the left, so it's less than. Okay, so you guys can look at it either way. But that's how you read the inequality. Same thing over here. 5 is on the right. Let me just extend the number line over here. So there's the number line right there. 5, I'm just going to say, I'm going to kind of like approximate. I'm going to say 5 is right here. You guys see the 5. So negative 2 and the 5 is over here. So 5 is on the right of negative 2. So right side, greater. So that's why Pac-Man is eating the biggest number. All right, guys. Now, something else you have to learn is perfect square numbers. You guys learned about different names in the first video for this lesson. You guys have integers, you guys have natural numbers, you guys have rational numbers, you guys have whole numbers. Now, we also have some special numbers that are called perfect square numbers. So let's go ahead and look at what those are. A list of perfect square numbers is right here. We have the 1, the 4, the 9, 16, 25, 36, 49, and all of these numbers right here. And there's more. You guys see the dots right here, keeps going and going. So there's more perfect square numbers. But what is a perfect square number? Well, a perfect square number is a number that you guys can break it down to the product of the same number twice. Now, what does it mean? Well, if you guys look at, let's try 16 right here, okay? So 16 is the product of 4 times 4. So that is the same number multiplied by itself 2 times. And guess what? We have a definition for that. When you guys multiply a number by itself 2 times, that means the square root of the number. So the square root of 16 equals 4, because you multiply 4 by itself 2 times, right here, 4 times 4, and that's going to equal 16, which is the product. Okay, you guys multiply and you get the number. So every number in this list, the 1, the 4, the 9, 16, 25, 36, is a perfect square number because you multiply a number by itself twice. It's a perfect square. Square means 2 times. You multiply the number 2 times. So if you guys think about it, let's look at 49. 49 is a perfect square number because if you think about the square root of 49, well, it's 7. Because 7 times 7 is 49. The square root of 64 is 8, because 8 times 8 is 64. The square root of 81 is 9, because if you multiply 9 by itself, 9 times 9 is 81. So every number here is a perfect square number. And let me give you guys this one. The square root of 144 is 12, because 12 times 12 is 144. Now, it's a very good idea, guys, that you memorize at least all of these perfect square numbers because in the future, it's going to help you guys make your life a lot easier when you know some facts. These are math facts. If you memorize them, you guys can do the math a little bit faster, and it's going to help you guys a lot. So let me just tell you guys, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5. You guys see the pattern? So this one is 6, the square root of 36 is 6, this one is 7, the square root of 49 is 7, 8, 9, 10, 11, 12, 13, and it keeps going and going and going. So I actually put the perfect square numbers in order, so you guys know what is the perfect square root. So how do we use perfect square roots? Well, we can start approximating a square root by using perfect square numbers. Now, approximation means that the answer is not the exact perfect answer, but it's an idea of what the answer is. It's an approximation. So in approximation, you guys can have different approximations, approaches. You can have a decimal number approximating. So you can have, for example, the answer is approximately 7.35. Or you can say approximately 0.7. So you're approximating with the decimal. You can approximate with the whole number to the nearest whole number. But right now, I'm going to show you guys with decimals. So in order to give a decimal approximation, you guys can see I'm reading right here, of a square root of a non-perfect square number, I will write out the perfect square number list above and see where that value will fall. So a non-perfect square number are the numbers that are not included in this list. So let me give you guys one. The number 5. The number 5, obviously that's more than 4, but it's not part of the list. So that's not a perfect square number. It's a non-perfect square number. I'll give you guys another one. 93. 93 is in between the 81 and the 100. It's not part of the perfect square numbers. So it's not a perfect square number. So if you guys want to find the square root of 91, now this is without a calculator. We're not going to use a calculator. 91 is almost a perfect square number, but it's not exactly one of those numbers. Now, 91 is also in between these two perfect square numbers. You see the 81? Let me show you guys the perfect square list over here. So 81 is right here, and the 100 is right here. So 91 is in between the 81 and 100, and it's kind of right in the middle. if you start counting 81, 82, 83, 84, 85, and you guys go to 91, and 91, you go to 92, 93, 94, all the way to 100. 91 is right perfectly kind of in the middle. So we know that this one, the square root of 81 is 9. So my answer for this square root has to be more than 9, because 91 is greater than 81, but it's less than 100. 91 is less than 100, and the square root of 100 is 10. So my answer is more than 9, but it's less than 10. And since 91 is almost perfectly between 81 and 100, well, the square root of 91 is approximately 9.5, right? We're not going to be exact. We're not going to have the right answer, but it's an approximation. So we are going to practice in a second, but I want to, first of all, practice how to compare numbers, and then we are going to find the square roots of different non-perfect square numbers. So you guys see some examples here. We have fractions. Now I'm going to help you guys learn how to compare different fractions. And I know that some of you guys are scared of fractions, but don't worry guys, I'm going to make it as painless as I can. So you guys see that in between the fractions we have a square. So there's a square, so every fraction, these ones are decimals, but we do have a square in between. So we want to replace this symbol or this shape, the square, with a less than, a greater than, or an equal. Now you guys already know the equal sign. That means that the two numbers are equal. So you guys can use that sign or that symbol. So let's look at the first one right here. 2/3 squared. So I'm just going to say blank. I don't know if it's greater than or less than. And we have 5, 6. So one way, there's a couple ways you guys can compare the fractions, but I'll show you guys the one that I like. And I think it's a lot painless to know which one is greater than, less than, or maybe they're equal. So this is the way you guys check. You are going to take the left side of the fraction, the top number, so this one here, and you are going to cross multiply. So what I mean is you're going to multiply with the number on the bottom here. So you multiply 2 times 6, and I'm going to put the box in between because I am going to check which one is greater or less than. And then I'm going to multiply the bottom number of the fraction, which is called the denominator, and the top number is called the numerator. So right now I'm multiplying the denominator, 3, with the number on the top of the second fraction, which is the numerator. So 3 times 5. So we know that 2 times 6 is 12. We know that 3 times 5 is 15. I'm going to put the box in between. You guys can tell me which number is greater, right? Or you can look at it the other way. You guys can tell me the number that is less than. So we know this number. Let's talk about smaller numbers right here. So 12 is less. It's smaller than 15. So guess what, guys? I'm going to have my inequality going this way. Okay? Now you guys can think about the Pac-Man. Pac-Man, this is the mouth of the Pac-Man, is eating the biggest number. 12 is less than 15. So that's the inequality for less than. So what that means, guys, is the fraction 2/3 is less than 5/6. That's how you check. You guys multiply across the numerators, the denominators, and you check the numbers. Now, here's the very important catch. You must start with the numerator on the top of the fraction. So you multiply these two numbers first, and that's on the left side. If you guys start with the bottom number, it's not going to work. It's going to give you guys the wrong number. So you must start with the numerator on the top number, and multiply across, and that's going to be the product on the left side of the square, right? So let's try the next one here. So the next one, careful with the signs. We do have a positive fraction, and I know this is a positive because we don't have a sign on the left side. Every time you guys do not have a sign, a negative sign on the left side of the number, we know that's a positive. It's an invisible plus sign. We don't have to write it down, but you guys do have an invisible plus, which is positive. So I'm going to start with the numerator. So I'm going to have 3 times the bottom number right here. Now, you guys already saw that we have a negative sign with this fraction. But guess what, guys? If you guys have a negative sign, let me just bring down the box first. If you guys have a negative sign, first, before you multiply, we are going to multiply 3 times 3, you bring down the negative on the same side. So notice the negative is on the right side of the box. So I'm going to put the negative on the right side of the box. Now you guys multiply, okay? Just bring down the negative and you multiply the number. So 3 times 3, that's going to be 9. And let me just put the number here, 9. And then I'm going to multiply 5 times the numerator. Now it is a 2. I already have the negative on the bottom, so I don't worry about the sign. So 5 times 2 will be 10, but we do have a negative, so that's a negative 10. So which number is bigger or which number is smaller? Let's talk about bigger number. Which number is the biggest number? Well, the positive number is always bigger than the negative numbers. And I'll show you guys that with a number line. If you guys have the number line here, let me put the 0 right in the middle. Negative 10 is somewhere over here. I'm just going to approximate it, guys. I'm not going to put the ones, units. I'm just going to say negative 10 is there. Positive 9 is right here. Like I said, guys, I'm approximating where the numbers are on the number line. But you guys have a visual. So the negative 10 is on the left side of the 9. So negative 10 is less than, which means if you look at it the other way, 9 is greater. So Pac-Man has to eat the biggest number. So there we go. So we use a greater. 9 is on the right side of the negative 10. So it's greater than negative 10. So my answer is greater than. That's the symbol that I need to use. Okay, so once again, we say that 3 over 5 is greater than negative 2 over 3. Okay, let's look at the next one. This one here, well, we do have two negative numbers. So first, let me bring down the box. So the box is right here. The negatives, I'm just going to bring those down. Negatives, I'm going to bring those down. So I'm going to have a negative right here, negative right here, and I'm going to start multiplying the numbers. So I start with the numerator, the top number, times the denominator straight across, 5 times 4, 20, and I multiply the denominator, 11, times 2 is 22. So we have negative 20, blank, negative 22. So I want to know which one is greater. So let's go ahead and do the number line. I'm going to have to compare the numbers. So my number line is right here. I'm going to say 0, since I need to go to the negative 20, all the way to the left side of the 0. I'm going to say 0 is right here on the number line. All right, doesn't have to be in the middle, guys, all the time. You guys can move the 0 anywhere you need to. I'm going to say, I'm just going to approximate. I'm going to say negative 20 is right here, and negative 22 is right here. Okay, so let's go ahead and compare the numbers. Negative 20, so let's look at the negative 20. Negative 20 is on the right side of negative 22. So that means that negative 20 is greater. So I'm going to use greater than. That's my symbol for greater than. That's the direction of the symbol, greater, the inequality. So once again, negative 20 is on the right side of negative 22, so it's greater. So what that means, guys, is the fraction negative 5 over 11 is greater than negative 2 over 4. Now, you might be thinking, well, Ms. Ortega, can you guys simplify this fraction? Yes, you can. You guys can simplify this fraction if you divide the top and the bottom by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. But guess what? The answer will stay the same. Because it doesn't matter if you reduce the fraction, the inequality will stay the same. So I'm just going to show you. If you reduce the fractions, negative 5 over 11, you guys cannot reduce that fraction. 5 doesn't go into 11. They don't have a common factor, which means that they don't have a common number that you can divide by. And you guys can divide or reduce the other fraction, negative 1 over 2. But it's still the same, guys. This fraction, 2 over 4, is 1 over 2. But the inequality stays the same. So now let's go ahead and look at some decimals and compare which one is greater than, which one is smaller, less than, greater than. So we do have a 0.987 blank negative 0.988. Now here's the thing, guys. Remember that if you look at the signs, this decimal is positive. We have an invisible plus in the left side of the number, and this one is a negative. So first, we have to understand what the numbers mean. So let's go ahead and use a number line again. So I'm going to put the line here, and I'm going to have the 0. I'm going to put the 0 in the middle for this time, right here. We do have a positive now, a positive number. But now, notice this decimal, 0.987, is not even a 1. It's a 0.9, which is really close to 1. No, remember that you guys can round your decimal numbers, and after the 0.9 it goes to 1. So this number is really close to a positive 1. So I'm just going to put a 1 right here, positive, and this decimal is really close to it, not exactly 1, but it's really close. So I'm just going to put a dot. I'm going to tell you guys where the number goes on the number line. So I'm going to plot the number. That's what we say. So 0.987 is really close to 1. So let's say right here, maybe not exactly right there, guys, but this is an approximation. So we have the 0.987, and if you guys look at the next decimal, negative 0.988. Well, yeah, this one, if you guys look at the 988, it's bigger than 987, but look at the sign. There's a negative. So what that means, that decimal is actually close to a negative 1. A negative 1 is on the left side of the 0. So that decimal is approximately right here, because the next number, same thing as this decimal, but it is a negative. The next number, 0.988, the next one, you guys can go to 0.999, and the next number, 0.9 after 999 is 1. So this turns into 1 eventually if you guys keep counting. But it's a negative, closer to negative 1. So I'm going to put negative 0.988. So guess what? The number, the decimal, 0.987, is on the right side of this decimal. So we have to use greater. Right means greater. So that's my answer, greater than. So let's look at this one here, okay? Now this one's a little bit tricky. You guys have a negative 0.99 blank negative 1. So first, let's use a number line. So there's my number line right here. I'm going to put the 0 right here. Negative 1, I'm just going to say is right here, the negative 1. So let's go ahead and actually plot the points. So negative 0.99, not even 1, you have a 0 there. So it's less than 1, but it's really close, really close to negative 1. Because the next number after 0.99 is, it converts to 1. So I'm going to put a point right here next to the negative 1. So this is negative 0.99. But guess what, guys? We do have a negative 1 exactly. So negative 1 is right there. They're really close to each other. So I'm just going to put a negative 1 right there. Even though it's on the bottom, you have a negative 1 there. But you guys can see where the numbers stand on the number line. And the negative 0.99, negative 0.99 is on the right. Now, like I said, guys, this one's a little bit tricky. Negative 0.99 is on the right side of negative 1. So that means that it's greater than, all right? So be careful with those inequalities. The number on the right is greater. So this number is on the right side of the negative 1. So it's greater than the negative 1. Now, you guys can also compare decimals with fractions. So those decimals with fractions, let's go ahead and look at them. First of all, notice that we can reduce the fraction here. So how do you reduce fractions? I already mentioned that with the other example with the fraction, but you can divide the numerator and denominator, the top number and the bottom number, by the same number and reduce. So I can divide the fraction by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. Now let me bring down the box right here, and let me bring down the 0.25. Now in order to compare numbers, you must have the same type of numbers. So here we have a decimal and we have a fraction. Those are not the same type. One's a decimal, one's a fraction. So you can go either way. You guys can convert the decimal into a fraction, or you can convert the fraction into a decimal. Let me tell you guys the fraction, okay? This fraction, 1 over 4, as a decimal, is actually 0.25. Or you can say this decimal, 0.25, as a fraction is 1/4. It's a quarter, okay? So 1/4 of a dollar. A quarter is 1 out of 4 quarters, so it's 1 over 4. So let's go ahead and change that decimal. I like to make it a fraction. So 0.25 is 1/4 as a fraction. Now we do have a 1/4 on the right side. I'm going to keep it a fraction, so that way we have the same number. And guess what? 1/4 is equal to 1/4. It's the same number. So we're going to use the equal sign on this one. Now for this example, we are going to estimate each square root that you guys see on the screen. We're not going to use a calculator, but we are going to make an estimation. Now remember that to estimate is to kind of find the answer, but not the exact answer. It's just going to give us an idea what the answer is. We're going to get close to the exact answer, but it's going to be an estimate. And we do have a different symbol than the equal sign when we estimate our answer. So if you guys look at the first square root, you guys have the square root of 15. Well, without a calculator, remember, we're not going to use one. In order to estimate what is the answer, first we are going to use the perfect square numbers. Now I do have the list of perfect square numbers up here. Remember that a perfect square number is the number that has a perfect square root. So for example, let me just tell you, the square root of 9 is 3, because when you multiply 3 by itself 2 times, it gives you 9. So that's why the answer is 3. The square root of 9 is 3. The square root of 49 is 7, because 7 times 7 is going to give you guys 49. So you multiply the number by itself 2 times, and it has to give you that number. So every number up here is a perfect square number because it has a perfect square root. Now to find the answer for the square root of 15, first we need to understand where the number is at in the list of perfect square numbers. Now it's not part of the list. Notice here we have a 9 and then a 16, but not the 15. But we know that 15 is really close to 16, it's less than 16, but it's really close and it's greater than 9. So we do know what the square roots of these two numbers are. We know the square root of 9 is 3, the square root of 16 is 4. So guess what? The answer for this one here, the square root of 15, has to be more than 3 and less than 4. So let me just put notes right here for you guys. I know that the square root of 15 is between the square root of 9, notice, remember 9 is a perfect square number, and the square root of 16, right here. I know the square root of 9 is 3, and I know the square root of 16 is 4. So look at the number that we have inside of the square root. Another name we can use for square roots is radical. So you might hear me say radical a few times. So the square root of 15 is really close to 16, and it's actually one number less than 16. So when we estimate right here, my answer has to be more than 3, but it has to be less than 4. It has to be really close to 4. It's going to be a decimal, 3 point something, but really close to 4. And since 15 is one number less than 16, well, guess what? I am going to estimate that the square root of 15 is approximately 3.9. So this answer right here is approximately 3.9 because the next number after 3.9 is going to be 4. Now, I'm not going to estimate to hundreds or thousands, or you can say 2 decimals or 3 decimals after the actual decimal, or 3 numbers after the decimal, but I'm going to use tens, only one number, and that's what I'm going to ask. It's just one number after the decimal, the tens. So the square root of 15 is approximately 3.9. So let's try another one. The square root of 170. Well, this number here is not part of the list, but I know 170 is right in between these two numbers. So 169, 169, and 196. So I know my answer has to be between the square root of 169 and the square root of 196, right? And that's where the 170, the square root of 170 lies, in between the 169 and the 196. If you guys count the numbers, these are in order, you guys can know that this number here is the 13th number. Or you can say the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this square root here is 13, the square root of 169. The square root of 196 is 14. So guess what? My answer for the square roots of 170, 170 is a number after 169. So guess what? My answer has to be more than 13 and less than 14. So I'm going to use 13.1, and that's going to be my approximation. Remember this symbol right here? It's not an equal sign, it's an approximation. So approximately 13.1. It's not the exact answer. There's more decimals. If you guys use a calculator, you guys will see the calculator will give you guys more decimals, more numbers after the decimal. But we're just estimating. So let's try the next one here. 111. All right, 111 is not a perfect square number. It's a non-perfect square number. But it's in between, right here, 100 and 121. So my answer has to be between the square root of 100 and the square root of 121. I know 100, the square root of 100 is 10, and the square root of 121 is 11. Now think about it, guys. 111 right here is in between 100 and 121. If you actually count, let me just show you here. If you actually count 100, 101, 102, and then you go all the way to 121, you guys are going to notice that 111 is right in the middle, right in between 100 and 121. So since it's right in between, it's right in the middle, you guys can say this is approximately the answer for the square root of 111 is approximately 10.5. And I'm using 0.5 because that's the middle in a decimal form. 10.5 is the middle, and then 10.6, 10.7, 10.8, 10.9, and then 11. So 10.5 is right in the middle. And since, one more time, I'm going to repeat myself, 111 is in between, right in the middle of 100 and 121. Think about it, guys. When you count, when you actually write down all the numbers, 111 is in the middle. So it has to be 10.5, around 10.5, okay? That's an estimation. Now the last one I have is the square root of 48. So let me move the screen here a little bit so we have more room. The square root of 48, that's not a perfect square number, non-perfect square number, but 48 is right in between here, okay? Now it is not in between, right in between in the middle, but it's next to the 49. It's one less than 49. So my answer has to be between the square root of 36 and the square root of 49. I know the square root of 36 is 6. The square root of 49 is 7. So since 48, notice here, 48 is 1 less than 49. We have to be 6 points and really close to 7. It has to be less than 7 because it's not more than 49, 48. So it has to be less than 7. So I'm going to use approximately 6.9, which is 1 less, you can say 7, 6.9, and then we have 7. So the square root of 48 is approximately 6.9. And that's all you do, guys. You look for the number in that list of perfect square numbers. And it's a very good idea that you guys memorize. There's some facts, math facts, that is really helpful if you guys memorize to find the answer. So if you guys memorize the numbers, all these perfect square numbers up here, it's going to be really helpful to find the square root of numbers, of different non-perfect square numbers. All right, guys. So this concludes my second part of this section. I do have the first part, so once again, you guys can go back and watch. It is about real numbers. And make sure you guys practice your math, and I'll see you guys later.